Alright, so if we talk about graphs of rational functions, we want to remind ourselves that a rational function is one where we have a variable in the denominator. So f of x and g of x up at the top there are examples of rational functions. We have two types of asymptotes that we deal with rational functions. And the notes here are a little bit incorrect. They say lines which the graph can approach but not cross. So that's true for vertical asymptotes, but not necessarily for horizontal asymptotes. So vertical asymptotes are where our function is undefined. So in this case, zeros of the denominator. So division by zero is undefined. So if I want the vertical asymptotes, I look at where my function is a zero in the denominator. So for the first one, I have a vertical asymptote at 4, because 4 minus 4 is 0. On the next one, if I factor the bottom, I'll have vertical asymptotes at plus or minus 1, because that's what makes the bottom 0, and division by 0 is undefined. So those are values that I cannot have. So those are lines that I can't cross. We'll see horizontal asymptotes are a little bit different in a second. Alright, so if we look at horizontal asymptotes, that's what happens if as x gets really, really big, so positive or negative infinity. And if the degree on the numerator is less than the denominator, then it goes to 0. We can see why in a second. So if we let x go to infinity, now we can't really do this, we can't really plug in infinity, but if we did, on the top we get 4 times infinity, and I think we can agree that infinity squared minus 1 is just about infinity squared, and so when we calculate those, we get, move that out of the way, we get that 4 over infinity, which dominates, is much bigger. And so we go to 0 if we have a higher power on the bottom. So it goes to 0. If we have the same thing, the same power on the top and the bottom, numerator, denominator, we do the same type of analysis, we can agree that infinity plus 2 is infinity, and those would cancel, and we go to 2. So we can't really plug in infinity. It's not a number, it's more of a concept. But that's what's happening with our horizontal asymptotes. So if we were to graph these, we're going to get something, the same type of picture over and over again. So we get the asymptotes, but we're also interested in the intercepts. So the x-intercepts are what happens where we have x comma 0. The y-intercepts are where x is 0. We see what we get for y. So to get an x-intercept, we have to make the numerator equal to 0, which means, in this case, is there any way to get a 0 on the top? There's not, so there is no x-intercept. Now, when I plug in 0 for x, I get 1 over 0, which is undefined, so there's actually no y-intercept for this one either. If I look at the next one, we'll see the difference. So if I factor the bottom, and I look for my x-intercept, that is how I get out of 0. And so to get a 0 out, I have to make x equal to 1. That will give me a 0 on the top and make the function 0. If I plug in 0 for x, I get the y-intercept. So I get 0 minus 1 over 0 squared minus 4, which is 1/4. So the y-intercept is at 0, comma 1/4. Now if we start to graph these things, we want to do 4 things. The vertical asymptote, the horizontal asymptote, x-intercept, and y-intercept. And as we go through this, we're going to put those points in and then use some reasoning to figure out what the graph looks like. Alright, so the x of the vertical asymptote is at 2, because that makes the denominator 0. The horizontal asymptote is 0, because as x gets huge, 1 over a huge number goes to 0. The x-intercept, there is none. I can't make the numerator 0. And the y-intercept, when x is 0, I get negative 1/2. So I put all those things on my graph, the vertical asymptote, horizontal, and my point. And then I have to think about what happens as I get really close to 2. So if I'm really close to 2 but less than it, that's 1.9999999. If I subtract 1.9999999 minus 2, I get a very small negative number. And 1 divided by a very small negative number is a very big negative number. So my graph down there looks like this. As I approach the asymptote, I go to a very large negative number. I do the same sort of thing as x is a little bit bigger than 2, like 2.000001. Subtract 2 from that, you get 1 divided by a very small positive number, which gives you a very big positive number. My graph looks like this. And I know there's nowhere where it crosses the x-axis. There's no x-intercept, so I know that it's all contained between those asymptotes. If we look at the next one, we do the same thing, vertical, horizontal, x and y intercepts. My vertical asymptote is going to be at negative 1. When x is negative 1, I get a 0 on the bottom. My horizontal asymptote is going to be 1. As I get basically infinity over infinity plus 1, I go to the same thing, I go to one quantity. So y is 1, I put that point on there. My x-intercept is when I want to get out of 0. That means x has to be 0. And my y-intercept is again going to be 0, 0. So I put that point on the graph. Now, we can cross this horizontal asymptote. It's only the M behavior. All right, so we can cross it if we want to. The vertical one we cannot cross. So we're not going to be able to cross that green line. Now, we do some analysis again, and we look at it as we get very close to -1, both above it and below it. And our graph is going to look like this. If we plug in some values, we see that we're positive and negative. So if I put in -2, f of -2 is a negative value. Sorry, it's a positive value. And so when I put this in, my graph looks like that. My other graph looks like that. I only cross the x-axis and y-axis at 0, 0. So what happens if I have more than one vertical asymptote? Well, I factor this bottom, and I'm going to get vertical asymptotes at plus and minus 2. So I put those in. And we do the same thing with our horizontal asymptote, which is going to be 0 in this case, because I have a higher power on the bottom. And my x-intercept is 0, -1/4. I'm sorry, my y-intercept is 0, -1/4. And my x-intercept is going to be what I get out as a 0, but I can't because I have a 1 in the numerator. Now, if I plug in some points, I find that there's no way that I can cross that x-axis that my graph looks like that between the asymptotes. If I put in the point -3, I get out a positive number, which means my whole graph is contained up there. If I put in the point 3, I get a negative number. I'm sorry, you also get a positive number, so my graph looks like that. It's all contained up there. So we put in some test points and we get our behavior as we approach these asymptotes. Another example, if we graph it, we're going to have vertical asymptotes at -3 and 1, and I'm going to have horizontal asymptote at 0. I know 0, 0 are the x and y intercepts if I plug in those values, and so I get that point right there. If I plug in x is -1, my graph is contained up there. If I plug in something between 0 and 1, like a half, I would get that I get a negative value. I'd be down here. So there's that piece. And then to get either side of the asymptotes, just plug in a test point. In this case 2, you get a positive number, it's up there. Plug in something on the other side, like -4, you get a negative number, the graph is down there. So there's the graph of that rational function. All right. We have some special cases where I have a higher power in the numerator. And this is a very special case because we're going to notice if we factor this, I have a common factor on the top and the bottom. Now, part of my domain is I cannot plug in a -2. I'm sorry, a 2. I get a 0 on the bottom. So I can't cancel that because I'd be changing my domain. But what this is going to look like is it's going to be a line with a hole, and the hole is going to be at 2. So I get a hole in this graph. I plot everything else as I would. So it has a slope of 1 and it has a y-intercept of 2, the line x plus 2. And then I have a hole at x equals 2. So my graph looks like that, like I said, a line with a hole. Same type of thing for the next one. We factor the top, and I see a common factor with the bottom. So I have a hole at -1. And I graph the line y equals x plus 4, and I have my hole at -1.